let's look at some ways that we can synthesize benzoic acid or benzoic acid derivatives using electrophilic aromatic substitution reactions. So one of the ways to do that would be to generate bromobenzene using an aromatic halogenation. So we'll generate bromobenzene. Then from here, we can generate the Grignard. So now we're generating the Grignard, and we actually had a laboratory video that made this particular transformation, the bromobenzene to the phenyl magnesium bromide. And then from here, although not pictured in the video on that process, we did in lab use carbon dioxide in the form of dry ice to convert this into benzoic acid. And then of course we'll need an acid workup step, like is typical when we're using organometallic reagents. And then it is possible to generate benzoic acid. Well, that's quite a process. And we can actually do something different to generate benzoic acid. And we can actually do this from a variety of starting material. We could use toluene. Like so. Or we could use some other alkyl benzene. Let's say we have our major product from our Friedel-Crafts acylation using 1-chlorobutane. Or we could even start from this reagent where we have a pi bond in the attached to the benzene ring. So this would be a styrene derivative. Or we could start from an alkyne. Or even a ketone. And you might say, well, why not the acid chloride? Well, if we have an acid chloride, we'll do something a little simpler than what we're about to do. We'll just add water, right? And if you have an acid chloride, if this was a chloride right here, just add water, hydrolyze it, you'll make the carboxylic acid. What if we don't have just add water situation? So any one of these. Well, it turns out that all of these under the same reaction conditions can be converted to a benzoic acid. So we can pick any one of these, and then we just need one of our favorite oxidizing agents, potassium permanganate. Now this is quite a powerful oxidizing agent. So we're going to add that, potassium hydroxide, and some heat. And then in the second step, because we have potassium hydroxide in here, and we'd really like to get to the benzoic acid, we'll have to protonate it. And then at that point, we can generate our benzoic acid. Of course, we may also be able to have some other groups on here and make something a little bit more interesting than just benzoic acid. Now, what are some of the limitations that we should talk about here, and how is this actually happening? Well, one limitation is that we cannot use quaternary carbons. So as an example, this starting material, which has a quaternary carbon on it, will not be able to be converted under the same reaction conditions. So it doesn't not work on quaternary carbons. We need a hydrogen on the carbon, or, and you might say, there's no hydrogen on this carbon, there's no hydrogen on that carbon. Or we need a pi bond, and both of these have a pi bond on them. This one does as well. And it also has a hydrogen there. So if we have hydrogens or pi bonds, we will be able to oxidize those molecules into the carboxylic acid. Now, the process for this and why it generates benzoic acid specifically is that it uses a radical mechanism. Now, we haven't discussed radical formation and mechanisms yet, but suffice it to say, this is an unpaired electron. And another thing that we can talk about radicals is that they follow a similar stability as carbocations. So if we have a methyl radical that's very unstable, then a primary one more stable, secondary more stable, tertiary more stable. But of interest to us is that a benzyl radical is relatively stable because it has a resonance stabilization effect. Same with a benzylic carbocation. So forming the radical in this position is favorable. For that reason, we're able to generate benzoic acid, even though we have quite a variety of starting materials that we can use. So I'll also just note here that we need a proton or pi bond in the starting material on the benzylic carbon, really. We could have a quaternary center somewhere else on this side chain, as long as we have the proton in the benzylic position. So this is kind of an interesting way of generating a benzoic acid. And we've already explored many reactions that carboxylic acids can be used in. So this could be an effective way of generating that useful synthetic material.